Alright, we are live, but I guess my connection is not that good today. Let's see how it goes. And also sorry for the delay. We are starting with 3 minutes of delay. Yeah, but my connection is really bad, awful. I have no idea what to do about it. I guess we're just gonna have to stick with it. I don't know. Maybe it'll get better. We can just hope. So I was just rewatching one of my yesterday's stream. The sound didn't look that good. I'm going to try to like fix that somehow. I don't know, but we'll see. We'll see. Anyways, yeah. Let me just make sure that the stream's alright. It is. It's seemingly alright. Okay, let's continue on what we were doing yesterday. So yesterday we finished the initialization process. That is what we have here. We just did the same exact things that the first example was in. So I am hoping that we did exactly what we were supposed to do. Let me just scroll some of these for better performance. Okay, yeah. So I believe we are doing exactly the same things that we should have been. We will be able to debug everything later on. So we wrote the initialize swap chain yesterday. That is the interface that our render is giving us for initializing the swap chain. And of course, the lifetime of the swap chain is in hands of the render itself. Anyways, that is what we have so far. The other thing that we needed to do was add depth buffer. I'm thinking that maybe we can just integrate these into that add uh, swap chain. Or maybe it is part of the add what would you call that? Maybe it is part of the close this. Maybe it is part of the add render targets. Oh, alright. So render targets are inside the swap chain, so I believe these two functions should be the same. I believe that depth buffer from the user's viewpoint is actually the same. Uh, it actually does contain the depth buffer. Like depth buffer is part of the render target, as the user would like to look at it. So I don't think that the user would go into details on what the depth buffer should be. So that is what I'm going to do at the moment. I could be horribly wrong. Like at render target. Yeah, we might need to like, for example, change our abstractions later on for more complex, like multi-pass renderings. Maybe shadow mapping even. We might need to like provide these, but that is something for later. For now, I'm just going to move this code here. That is where get our swap chain. Let me just check this. So that adds a render target. Maybe I should provide the add render target uh, interface, because that is a more general thing to do. Let's see what we need here. So I'm joining back with my secondary network connection. It is not that good. I have lots of frame drops. So uh, I'm trying to fix my primary connection for now. Render target. Let's see if this works or not. It is not. It is. It is really awful. But I guess it's better than nothing. That was an unexpected turn of events. Alright, we should be back. Sorry for the inconvenience. Uh, yeah, these things happen. I don't have that steady of a connection. I guess we have a steady connection now. Sorry about all of that. So, yeah, let's get back to it. So you were writing the add render target interface. That is going to take a render target descriptor. And yeah, we're going to just add it to our map here, which is we're going to have a map of render targets. As simple as that. We have a map of render targets. We are going to construct it here. That is going to be default constructed. We're going to add a render target to it, which is another copy paste code. I will need to remove all of these copy paste codes. But that's something for later. Render target, I believe, can go here. And yeah, that should be alright. Except that this is going to be different. And I'm probably going to have to add render target. Going to have to change this add render target interface here. It's definitely not taking constant. Oh, it is. Is it? Could not find add render target. Isn't that this? Oh, it is taking add constant reference. Constant pointer. So we are fine on that. Mm. And yeah, let's just do the renaming. That should be fine. That right there should do the trick. And our remove is going to be just so. Let me just check this and see. Yeah, I was worried that this render target descriptor that would be dependent on something that only the too long code lines you have. Okay, Igor. Yeah, that is correct. Like this, I don't like this part of the code, and I don't have a solution for it right now. I will try to like figure out a way to abstract this out. So the reason that the code line is here is just so long is that we actually know what type we want here. So we do know what the element type of this, for example, let's not name it samplers. Uh, let's name it, yeah, render targets. So here in the render targets, I'm just specifying the type of the render aware unique pointer that is for our render target, and I have to restate that type here. So that is what is causing the problem here. Let me just restating this type. I really didn't have any other solution at the moment. I will try to come up with a solution for that. I completely agree with you. And another problem that um, is is causing the long line size is that I have to do this. Like I'm trying to pass the render target here, the deleter for my render target. I have to also pass the type of my render target here, which is a problem because the type of the render target deleter is deducible by the function pointer by the function itself. Like I could deduce this from that. So yeah, this is because I'm sticking to C++11. If I had like C++14, I could get rid of this. So that's the other part of the problem. So there are actually two reasons that I'm doing this kind of crazy code here, which I don't like either. One is that I'm limited to C++11, and the other is that I actually am not. I don't know any good design that would eliminate this here, this type here. Maybe I could use, now that you mentioned, maybe there is an interface. Let me just bring up a browser for myself. Alright, let's see, maybe the stud map would give me the element type unordered map. Alright, let's see if I can actually do, and the Google is going to ask me if I'm a robot or not. I definitely am a robot. That is a tricky thing there. You got bosses, there are no bosses. Bosses. Come on. You, people don't want to see me verified I'm a human on stream. Okay, so it's the unordered map. I hope that's the last time that that is happening. Let's see if the unordered map provides me an interface that I would be able to like get this from. Concentrator type, value type, yeah, that is okay. No, key type, map type. All right, we can use that. We can definitely. Oh, can we? Ah, Let's do it. Let's do it. Ah. Yeah, I found my losses. Let's do this then. Using shader type, shader putter type, shader smart putter type. Alright, and do that. So that is going to replace my add shader. Where is it? That is going to replace this part of the code. And of course I'm moving this up here, adding a space there. This is going in there, add a space there, add space here, and we are done. Alright, let's do this for everything. That that does make the code a bit simpler because we don't have to like keep consistency between two lines of code. Scripture says. We don't need this. And here goes that. Render target. And there goes that. uh, are you? I guess you're pointing out that I'm using too many usings. Yeah. I mean, the C interface is not really C++ friendly. I don't know really how to uh, make the code any better, but this is going to help a bit. Like I am reducing the total line count and the actual code duplicate. So that line was exactly repeated up there. If I were to change it, I would have to change this line as well. So yeah, we're getting some ugly code up there, up here, but we also have some better looking code like here. So yeah, it isn't really making that much difference. It is simplifying some stuff, but not that much really. I cannot do anything about that maybe. Yeah? No. Alright, let's remove this one here. And I already have a bug. I have a misspell here. Replace them all. Alright, here goes this. Yeah, you could you could blame me of providing uh too many abstraction layers there. That is that it is maybe reducing the readability, but I guess it is not reducing the readability because this is pretty readable. It's an unordered map of uint PDR to uh, render target to smart pointer type. That is readable to me. Same here, I guess. Anyways, let's see if this. Sorry guys, I got disconnected again. Alright, I'm back on. Yeah. Alright, this stream is pretty live. Okay, I mean the latency is really low. So I'm going to just copy paste this descriptor, put it, I'm doing some frame drops That is why you're experiencing buffering. My connection isn't good at all today. I don't know what the problem is. Like yesterday it was pretty decent. Today it is just awful. It is horrible. Add render targets. Alright, render, add my render target, and there goes my that. Oh no, not that. Let's change this name as well. Yeah, I'm going for depth render target. Replace them all. Okay. I'm not sure if we're going to need the. We definitely are going to need our. Let's rename this again. This is not our render target, is it? This is our render target. Const auto render target handle. That is my render target right there. This is render target descriptor. Alright, should be fine. And that is how we achieve this. So we were just following the process of our load function. So that is add and swap chain. We did that. Add depth buffer. We just did it. I'm not doing any UIs, so that can go away. And what do we have here? Alright, we need all of this, but I don't know vertex layer where these are used. Add pipeline. Alright, that is an interface we're going to implement. What pipeline is this? Oh, that is pipeline settings. Okay, this is superior pipeline. We're not going to need that. We're just trying to get the example render a single skybox. I'm going to need that one. That is going right there. And of course, it's going to scream at me about all the variables that I just did not provide. So this is going to be an interface for my render here. So let's go about doing that. And the process of that is going to be pretty much the same. I am probably going to abstract out these two, like these are the lines that are pretty much recurring, same as these add functions here. These are pretty much recurring as well. So yeah, I'm not saying that this is the best abstraction that I've got. This is a work in progress, and we will try to get everything fixed up as we progress. So pipelines, that is my pipelines. That is going to be pipeline smart pointer. Maybe I should use unique instead of this smart here. Let's do that. That is more descriptive of the type. Type is actually smart pointer rather than unique pointer rather than just being smart pointer. It is more descriptive. Remove pipeline, and this is the place that I have to do the stop because just because of the standard version. And just as Igor uh, advised me, I added another missing statement here. Yeah, the code is in the prettiest. This is a work in progress. Hopefully, we will get to better code as we progress. So that is going to be what is it going to be? It is going to be pipeline, and that is add pipeline. Right, and that is going to be pipeline descriptor, I believe. It is going to be pipeline descriptor. I'm not retyping descriptor. Pipeline descriptor. There goes that. Add pipeline. Yeah, I'm feeling that we're lacking a level of abstraction here, but that is going to be left for later. I'm just trying to get uh oopsie, what the hell just happened there? I'm just trying to get this code to compile as soon as possible so we can actually test it. What would be there? Yeah, and this is our pipeline handle. Pipelines. Yeah, as soon as we get a simple rendering, if you wanna do render object inside pipeline, better create extra functions for that. Not a smart pointer with logic, or I missed something. Uh, I'm doing smart pointers just for the lifetime management. Yeah, I know that I will probably later on need to like actually provide a good abstraction of pipeline. Uh, like to skybox pipeline. That is going to be a higher level of abstraction. Like that abstraction would be good inside the uh, example. If you watch my previous sessions, I did some kind of abstractions like that in let me just show you here. So I did something like that in the material playground uh, example. So skybox. Let's go to where was it? Compute PBR maps. Understand. So yeah, as you can see here, let me just see if I can find it. I can't. Why is it? It's not here. Let's compute PBR map. Did I'm missing something here? Or maybe was it at pipeline? Let's go to. Oh yeah, here that is. So this is panel to cube map pipeline. Like this is doing this is like your function that you said do skybox pipeline. This is something similar. So what it does, it just has this panel to cube map pipeline. Just compiles. I mean, it just constructs itself, and then there is this apply command. So it takes a command as input, and then it does whatever that is needed to create a pipeline, create that we need to draw a uh, draw the skybox. So yeah, that is a higher level of abstraction. That is going to be inside the example if I am going to do it. But for now, I am just trying to get a simple render of my skybox so that I can realize that I can make sure that my current abstraction works. So the current abstraction is just a render. It is called render, so it is pretty generic. And the main reason for this layer of abstraction is just to handle all the object lifetimes. I don't want to do like messes uh, like this. We have, okay, let me bring that part back. So we're just manually, where was that? We're just manually adding and removing everything. So whatever I add here, I have to remove it somewhere else. Like this will cause such things. So that abstraction layer is going to handle all of that. Anyways, we were doing add pipeline and remove pipeline. Okay, that seems fine to me, and you should be able to use it. However, I am missing some stuff still. Well, let's get back here. So I'm going to change this render add pipeline, and that is going to get my descriptor skybox pipeline. Okay, that is going to take one input as I believe. Let me check my interface again, and that is going to be pipeline descriptor. We will get to actually find that. Okay, so this is part of the code that we need. Let's see what else we need. We need this vertex layout is being initialized here. That is my vertex layout. Let's see. We need pipeline settings, so that I believe is a reference. Let's take these as well because I believe maybe we don't need them. Let's just take them. We might have to get rid of it later. And the other thing is, yeah, let's copy paste this here. Let's see. Call mode is the first element. I am going to put it right there. Same as here, call mode is the first element. Was it the same code? Was this the same type? Yeah, this is the same type. What is this? Sphere. Okay, we're not doing the sphere. And depth descriptor, alright. Let's make that const as well there. And what is this? Depth test, boolean, depth right, and depth function. Are those some things that we're actually, yeah, we are setting those as well. So this could be done like so. And that is going to be const as well. And I'm pretty certain that I'm going to enter that is going to be done like so too. However, this one cannot be const. Anyways, descriptor blah blah. There goes that, and skybox draw shader. So this is another part that we are going to have it to do set for it. Describe box draw shader. So we're adding shader in the initialization function. Add shader here. So this would have to become member variable rather than sorry about that. Rather than just a local variable. And again, this is some some part of our dev because I'm going to do a reinterpret class here. To shader pointer. So this is an implementation leak. I'm going to put a to do here. We are going to provide better interfaces to this. You need to keep handler result in global scope. Did you? Yeah, I'm going to avoid all of the global variables so far. So far, all the global variables that we have is for the resource loader that we haven't been able to actually abstract because we're just abstracting the render for now. I will abstract the resource loader as well. That is going to manage all these global variables. But for now, I'm just avoiding all global variables. Uh, if I need anything, it is going to be my member variable as this shader handle. So that is what I'm doing here. So this is to do. This is an implementation because the user doesn't know that this shader handle is of shader pointer type. The renderer does. So it is the renderer's responsibility to set this variable, set this to do this reinterpret cast. This is just showing some lack of interface for now. I'm going to add the to do and move on. However, pipeline descriptor. So this is my pipeline descriptor right there. Pipeline graphics descriptor, that is what that is. My connection is just awful today. That is just weird. Like I had good connections last few, I don't know, maybe 5, 6, uh, 5, 6 streams, but this time it is just off. Anyways, this is not complete because we're keeping some state from here. So I will need to copy paste this as well and remove the redundancy. So we need to do that. Alright. Depth state. So what is this depth state descriptor? That is depth state descriptor right there. Swap chain. Oops. Our renderer is not providing the swap chain to the user at the moment. That is easy to do, but that is also some kind of uh, implementation leak. So let's get rid of this depth state as well. So our depth state should be removed here. Right, where was it? Let's see. Program should be removed. Alright. So root signature. We have We have the root signature. We're just going to have to. You tomato plugin? Are you too expensive? What is tomato plugin? What do you mean? Tomato plugin? Was it a pun? Sorry about that. My throat is really scratchy today. Nothing is going well today on the stream. Like this has been one awful stream so far, and we are 56 minutes in. Visual Assist, is that a plugin for Visual Studio? Visual Assist. Let me check that. ReSharper. Plugin for Microsoft Visual Studio developed by Tomato Software. The plugin primarily enhances the IntelliSense and syntax highlighting. It is also enhanced code suggestion. Oopsie doo. It is kinda expensive, like $49. I don't usually use Visual Studio. That's why I don't really have any plugins or actually know much about it. But yeah, I I could be using that maybe later on. I don't know. I don't feel any. I don't really feel lacking. Maybe I don't know. I don't know. I don't know. Maybe I should be providing interface from the render to get me these. And sample quality, root signature, format, that is from the diff buffer. So what I'm trying to figure out right now is how to provide a proper interface for this. Because I could be like exposing my swap chain. It is not that difficult to expose the swap chain for me. But I don't really want to do that. This whole thing is going to need some proper abstractions. Root signature and depth buffer. M format. What is this M format? What is the type of that? Let's just dig a bit deeper inside this. So depth buffer M format. What is depth buffer? It's a render target. Where about that? Why does this need a depth buffer if we actually are not using? Why you set data from one structure to another? I don't know, Igor. I don't really know. Maybe they want to like they I believe they wanted not to redo this like they wanted to keep the consistency because I believe that they have the M format. I believe that is the case. They are just trying to always be consistent with themselves. Let me just see where we added our depth buffer. Depth and that is our depth buffer. M format. So you have M format here. So the only reason you would try to do this kind of thing, I believe, would be that you don't want to type this the second type. So if I were to go and change this, I would need to change this as well. But that has some other solutions. Like I don't really need to access my depth buffer for that. I would like do this maybe. Const expr auto. I don't care what the type is. auto uh, depth buffer format. Oh, what the hell am I doing? Come on, can I really not do a copy paste? That is what I would do. That's stencil format. Alright. So we are limiting our problem here. Now we need the root signature. Root signature is really easy to do. What value is it? PD buffer value. What do you mean user can't forget about PD buffer value? I need extra time to search the value is it? Oh, yeah. Oh, okay, I get that. So you mean that the user would be confused where it was set, and to actually realize what it is set to would be difficult, and I believe that is what you mean. Yeah, I agree with that. Anyways, we need to make our root signature a member variable. Let's do uint pdr again. Root signature. Alright, let's just find where we constructed our root signature. Add root signature descriptor set. Oops. We are actually not exposing the root signature at the moment. So this add descriptor set, let's get into this function. This add descriptor set provides an interface for the descriptor set, but it also constructs the root signature itself. So what our descriptor set is, our descriptor set is a pair of unique pointers. Let's go. I like the descriptor set. Yeah, it's a pair of unique pointers. It's a descriptor set and a root signature. So we're trying to not expose our root signature at all. I do not know at the moment why we would need our root signature there. Uh, the design for this root signature and descriptor set is kind of vague to me, to be honest. Root signature. We could expose our root signature as well. Like it's not that difficult. I would just need to provide one more interface to add root signatures, and then another. Then I would change my add descriptor set interface to just take a root signature and the rest of the parameters. Let's maybe do that. Let's do that. Why the hell not? Let's provide the interface. I really wanted to like hide the root signature from the user as long as I could. Like it is kinda confusing. That is what that is. It is confusing why we would need the root signature here. Because we are already passing that in the shader. We're, we're setting the shader here, right? That is our shader program. So our shader program knows what the root signature is. Why would I add that to the pipeline as well? That seems kind of redundant to me, to be honest. But that is what the interface is, and that is what I'm going to provide. So this is going to be root signatures. And this is going to change here to descriptor set. Show project structure, I'm not using any. Oh, okay, where's my Solution Explorer? My project structure isn't that complex. I have a single header file here, the render interface, and that is my CPP. So there are just two files. So the render interface is the one I'm here at, and the other, my source file, is structured code example. And sorry for the delay. There's some delay between you watching and me actually reading the chat. So there's some delay there. Anyways, root signature, descriptor set. That is what I'm going for. Descriptor set. Set. Oops, no. Okay. No descriptor set. I could just copy this. Why am I typing it? That is for descriptor set. So we just unfolded one abstraction layer into two, and we kind of expanded our interface. I didn't really like to do that, but it seems like we have to. Root signature. Okay, that should be fine. So this no more has any. Okay, let's keep that for now. I'm going to need to figure out what I need to construct this. Anyways, let's just firstly fix my descriptor set here. Add descriptor set. Add descriptor set. Where is it? This is update descriptor set. Add descriptor set. Right, my add descriptor set is going to take that is the signature. That is correct. And it is going to construct a descriptor set. Set unique pointer. Let's let everyone know that this is a pointer. Alright, I just need to change this part of the code. And instead of root signature descriptor, I'm going to get a root signature handler. To join footer, and we're going to call this root signature handler. Descriptor set unique pointer. Reinterpret cast this. Yeah. To what should I reinterpret cast this to? Root signature. The root signature pointer, and then we take the reference. And this part is going to be what I will be copying from the old abstraction. Not that abstraction, where is it? Yeah, here. This descriptor set descriptor. Maybe I did a bit wrong there. Let's copy this, move on to our code. You use too much cast functions. I know. Firstly, I don't want to use any like implicit C style casts. That is one reason I'm using It will cost you FPS and program speed. Reinterpret cast is nothing. It literally is nothing. So you could check that like in Compiler Explorer. So reinterpret cast is safe to do. It literally costs nothing unless you're doing dynamic cast. You're probably not going to pay anything. Dynamic cast and user defined static cast. Those are what are going to cost you some performance. The rest should be safe. And hopefully after we actually get the draw, you will see. I will be able to prove my points. For now, you just have to maybe trust me on that, or maybe not. Let's do this. So yeah, I'm mostly doing reinterpret cast. Reinterpret cast is mostly just okay. And of course, you're going to tell me that, ooh, that is a long line you have there, and you would be correct. So I'm going to name this descriptor for multiplayer games, and render pipelines will cost reinterpret cast too. Why would you say that? Like, how would a reinterpret cast make any difference for multiplayer games or maybe render pipeline? Because from what I believe, reinterpret cast is literally nothing. Like let's do what? Let's start to main. Let's take a void pointer. Do my cast and return reinterpret cast of am I typing correctly? Cast of in pointer void pointer. My input, let's call it foobar, maybe. And of course, let's do the over 3 thing here. So what it is just doing is just taking the RDI, which is the input, that foobar, and it's just moving it to RAX, which is our output. So this is just a move here, and that is because, of course, this is a function. If I were to like make this int, that would be the exact same code. So that is literally no overhead there. I believe, yeah, the reinterpret cast is not going to cost anything for us for now. And that is the reason actually I'm returning the uint_ptr as my handle, so I can simply do a reinterpret cast instead of a look into the map, look up into the map. So I believe that is the case, but if you have some maybe sources that I could maybe read on that, I would appreciate it. Just send it in the chat. I would like to read more on that if you have any sources that support that idea. There goes that. Maybe you're right. I will check. Yeah. Okay. We are 15 minutes over time. Let's see. I believe this does everything that we need to. Let's check our old abstraction code. Yeah, you don't need to pass that to root. Okay. Okay. Where were we? We were here, our root signature. at this set. The code at the moment is not compilable. That is not something I like, so I will try to get it to a set that it is actually compilable, and then add root signature. Add the scripter set. Scripter set. I will get it to a level that is actually compilable, and then we will end this for today. Okay, seems fine to me. It does seem fine to me at the moment. We need the same kind of interface for add root signature. Remove root signature. So I don't like this combined with that. If I were to like make my descriptor set dependent on my root signature, I'm just trusting on the user to know in what order to call these, and that is, so far as I believe, the code smell. Code smell wiki. Basic class views, no, only form for variables, no data clump, downcasting, no psychomatic complex join, nope. Boolean variable, uncontrolled side effects, no. Complicated code contrived complexity, those are not the things that I'm looking for. Order. Large classes topic. Let's go to anti-patterns and design. So it's the two software, right? Anti-pattern software design. Focus application flow, no. Okay, sequential coupling. That is that. That is a design smell there. Sequential coupling, a class that requires its method to be called in a particular order. That is called sequential coupling. So here I'm just asking the user to know where to call remove root signature. Remove root signature should be called after remove descriptor set. The descriptor set that depends on the set root signature. So that is not good. I don't like that. There are kinda loopholes, kinda maybe missing parts in this design. Over time, I will try to fix them. Let's not worry about them at the moment. I haven't seen the big picture yet. This code is going to get a lot of hammering. Root signature descriptor. What I'm going to do is simply just add the root signature here. Remove that one. Root signature. That is root signature this pointer. My connection today by far has been the worst. Like, it is just awful today. I don't know why. What the problem is. I hope I am back. So yeah, this has been just quite awful. Dreadful indeed. Root signature goes there. Render. I'm just going to get this to compile. Add root signature. Okay, that works fine there. I have to make this a member variable. And we're going to do some more implementation leaks here. Root signature, reinterpret fast. Did we just lose connection again? Ah, my connection is just awful today. That is such a headache. Root signature pointer. Let's just get this code to work. I cannot wait to get this code to work. Okay, so M format. What is that? And by a pointer to that M format. P color formats. It's a pointer to several color formats. Sample count. Okay, I believe we can get all. I'm really sorry for bad experience and all the buffering. I just want this stream to be over as soon as possible so that I can go and fix my connection maybe for tomorrow. This has been one dreadful stream. Anyways, let's just finish this. Where's my add swap chain call? Add swap chain. Do I not have an add swap chain? Okay, it's init swap chain. Okay, initialize swap chain here, and that is what I'm using for swap chain initialization. So maybe I don't know how I can get all these from my swap chain. Maybe I could provide an interface from the render that would return this, like some getters. I could probably do some getters. P swap chain, blah blah. Render target format. We don't even have our render target format there. Show skybox.frag, maybe your shader. Alright, uh, it is just a default example shader. Skybox.frag. So that is this. It is just like rendering six sides uh, of a cube map. It is nothing really that interesting. I'm just trying to get one skybox rendered. It is just returning the sample, blah blah. Nothing really that interesting. And yeah, let's get this done. Let's get this done. This is getting painful. So one thing I'm going to do is write three getters. I will write three getters for these: sample quality, sample count, and format. So that would be, let's put it out, let's make it auto for now. Get swap chain format. Same with get swap chain sample count, and then get swap chain quality. I believe those are the three we need. Sorry about that, my throat is just sample count, sample quality. Alright, let's just provide that with types because blockchain, render target, and let's see. pdef sample count. Where is the sample quality? Okay, it is Uint32. So I believe these are all, these two are Uint32. What about the swap chain format? What is the format type? Format is tiny image format. What I'm going to do here is check. So if not, so yeah, if we don't have the swap chain initialized, we will need to throw it. So that's going to be, if not swap chain is not initialized. I will rethink these designs, don't worry about them. I will definitely rethink and maybe get to better state here. Return, what do we return here? Our swap chain. Alright, let's just get over with this. That has been enough already. can't be assigned to an entity of type sample count. What? Maybe that is of type sample. I don't know why swap chain is not acting properly at the moment. Swap chain. I don't know. I don't know. This should have worked fine. It isn't. We'll catch that at compile time. Alright, and this is probably the saying that it is not constant as what it should. What was the error? Missing semicolon before identify root signature. Oops, you don't need that. No, not root signature. Can I convert the pointer to unit pointer? Alright. Come on, code, just compile. Let me finish this stream. We've been over 36 minutes already. Hi. Okay, we got a compilation. And it actually did not crash, so things should be fine except that... What is this? Yes, debug. Worker present. Failed assert. Make window association. Initialize swap chain. Alright, I don't think that is that's a big issue there. I would just need to call the deinitialize swap chain here on the onload, I guess. Okay, that worked. There we have it, and that is our memory problem that we are aware of. Alright guys, thank you for watching, and see you tomorrow.